A star just collapsed, and what happened next should not be possible. That is a statement that should make you pause. It should make you sit up. It should make you lean in closer. It should make you ask a simple, profound question. What did we miss? For all our knowledge, for all our powerful telescopes, the universe can still present a puzzle that defies our expectations. We look out into the vast, silent darkness. We think we understand the grand cycles of life. But sometimes, something happens that reminds us just how much we have yet to learn. To understand why this event was so shocking, we must first understand the rules. How does a star normally die? The process is usually dramatic. Their long lives are spent fusing lighter elements into heavier ones in their scorching cores. The delicate balance between the outward push of nuclear fusion and the inward pull of gravity is broken. It collapses catastrophically. The star's outer layers are blasted into space in a brilliant, titanic explosion. For a few weeks or even months, this single dying star can outshine its entire galaxy. What is left behind is a super-dense remnant. Depending on the star's mass, this remnant could be a neutron star, or it forms a black hole. A region where gravity is so strong that nothing, not even light, can escape. This is the established narrative of stellar death. What happens when a star decides to exit the stage not with a bang, but with a whisper? Astronomers pointed their instruments toward it. They expected a familiar celestial drama. Instead, they witnessed something far stranger, something far more mysterious. The star simply faded away, like a ghost in the night. No explosion, no grand farewell, just an unnerving silence where a brilliant point of light once shone. This event has forced us to reconsider everything we thought we knew about the final moments of a star's life. It is a cosmic mystery, a whodunit written in the language of light and gravity. The scene of the crime is a distant galaxy, millions of light years away. The victim is a massive star, many times the size of our sun. Scientists immediately began to formulate theories. Perhaps the star was not gone, but merely hidden, including infrared, which can penetrate through dust. But there was no such glow. The speed and the lack of any new light made a quiet transformation unlikely. This led scientists to a more radical idea, the failed supernova. The outward shockwave never gets enough power. Instead of blasting into space, the star's layers simply fall inward. As the core collapses, it forms a black hole directly, and it feeds. There is no grand explosion, only a brief, faint glimmer as the last bits cross the event horizon. Another possibility, a direct collapse. The star is so massive that it does not even attempt a shockwave. It simply gives up. It is as if a celestial switch was flipped to off. Picture that bright point of light on a vast black screen. It does not flicker. It just dims, steadily, relentlessly. A slow, graceful exit from existence, winking out over months. The space it once occupied now looks the same as the space around it. But something immense has changed. A star hundreds of times larger than our sun, containing more matter than 1,000,000 Earths, simply ceases to shine. It is a cinematic moment that ends with a slow fade to black. And in that blackness, a new monster is born. They break the simple rules we thought we understood, and force us to rethink the life cycle of the most massive stars. Why does this worry us? Why is a quiet stellar death more than a curiosity? Astronomy is the science of light. Our rules are based on decades of bright, visible events. If stars can die quietly, our cosmic census is incomplete. Our models are incomplete. We estimate black holes by counting their births. If they are born in darkness, there may be far more than we imagined. The universe could be far more gravitationally dominated than it appears. The heavy elements essential for life, carbon, oxygen, iron, are forged in massive stars. Supernovas scatter them. Direct collapse swallows them. If common, it changes the budget for building worlds like our own. The universe might be hiding its most profound transitions in plain, silent sight. What if these silent deaths are not rare exceptions? What if this is a common way for the most massive stars to end? It would mean we have been missing a huge part of the story. Giant stars could be disappearing all the time. We have been searching for bright flashes, and not for the quiet holes they leave behind. Now we can begin a systematic search. Look for faint afterglow. Listen for the soft chirp of space-time. The vanishing star is a signpost toward a new astronomy, the invisible, the silent. Either we have been miscounting all along, or we have discovered something wonderfully strange. What if some vanishings are not natural? A goosebump thought, but for now, the data points to physics, not fiction. We are beginners on the shore of a cosmic ocean. Discovering a new kind of wave does not mean we know the depths. Astronomers are already hard at work, trying to solve this puzzle. They are designing surveys to hunt for vanishing stars, comparing today's image with yesterday's. When a candidate appears, they mobilize and look closer. The star in NGC 6946 became the prototype. Others are emerging. Science moves in steps. Strange events push us forward. For now, the star that collapsed the wrong way remains a ghost in the cosmic machine. It is a call to watch more closely and to think more creatively. It is a call to be humble in the vast, silent darkness. This may be the beginning of a whole new chapter. We watch. We wait. We wonder. And the sky keeps its secrets close. What else is happening out there that we have not yet learned to see?